Welcome to Carlson Scan3D. This tutorial will walk through setup and best practices for capturing accurate and detailed color 3D point cloud datasets from your Windows-based 3D scanning system. The first screen you see here is what's called the gallery view. It's empty right now as we haven't taken any scans yet, but this is where you'll see thumbnails populate of your scans that have been captured and saved to the default folder of Documents Scan3D Data. Before we do start our first scan, we're going to cover a few settings briefly. Most settings should generally be left on their defaults, but there are a couple things we should confirm here before we start our first scan. The first is our license key. You will have been prompted to load this in the first time you opened Scan3D after downloading it. So it's already been loaded in this case, but we can confirm that by going to About, License Info at any time, where you see that my Scan3D license key is perpetual and successfully loaded. That will remain the case anytime I open Scan3D moving forward, but you can check at any time under this Settings tab. The next setting that we'll want to confirm before starting our scan is the calibration status of our 3D camera. Before we do that, we do need to make sure that your RealSense 3D camera has been successfully connected to your tablet. You can confirm that by seeing the new scan button on the screen here. That button will not show up if the camera has not been connected successfully. Connecting your camera is as simple as plugging it into your USB 3.0 or higher port, and if you do run into any issues with the camera not being recognized right away, we recommend you double check the connection of your cable and sometimes swap the direction of the connection into the camera, as these RealSense cameras have been found to sometimes be a little bit finicky in that regard. Now that we've confirmed the camera has been connected successfully, it is equally important to make sure that our calibration file has also been loaded successfully that is associated with that camera. This calibration file will be delivered electronically, just like your license key, and should only need to be loaded one time. But before you load it, you will need to download this file onto your tablet and make sure to save it into the folder Documents Scan3D Calibrations, where you can then activate it from within Scan3D. To perform this initial activation or check your calibration status at any time, you want to go to Settings, Sensors/Cameras. And here we see our connected Intel RealSense D455 camera highlighted in blue. So we'll tap on that and then navigate over to calibration on the far right, where we do see that no calibration file has been loaded yet. So we navigate down to the Scan Calibration folder button in the bottom left and select that to automatically scan that folder that we had already placed the file in and have the camera and software be updated automatically. This is a one-time procedure and should automatically load every time you connect your camera from here on out, but you can always check at any time by coming back to this screen here. Each calibration file is unique to your device and will automatically improve the accuracy of your results based on the specific calibration to your camera. The remaining settings in this Sensors/Cameras tab should generally be left on their defaults. The other settings that we see here include scene rendering, scene capture, other advanced settings, units, and more. We also have a link to download and print April tag targets, which, as you'll see in the demonstration later in this video, are an important and recommended addition to your kit. And lastly, we have the About button, where you can view your license information and version number to check for updates at any time. The majority of these settings should generally be left on their defaults, although once you are comfortable with your kit, we do recommend reviewing each of the different options available to you to see if there may be some changes that you do want to make later on. Alright, so now that we've gotten those basic logistics out of the way, let's go ahead and start our first scan. To begin your first scan, you simply press the New Scan button on the left side of the screen, and your Scan3D software will connect to your RealSense camera in a matter of seconds. And we now see what the 3D camera sees. You'll see that today we're going to be scanning an outdoor environment, covering a portion of a building exterior as well as some of a parking lot and the surrounding land area as a good example of an outdoor scan situation you may find yourself in. You'll notice that I have 3 April tag targets here at my start point, And this is the simplest and most recommended workflow for these targets, where you want to always make sure to start and finish at a set of 2 to 3 of them. Technically, even this is optional, but it's a very easy process because all you have to do is put them on the ground, start at them, and finish back at them, and it'll automatically improve the accuracy, especially of larger scans, by closing the loop on those targets from the start to the finish of your scan automatically behind the scenes. So when you are ready to start your first scan, you want to point at the area that you're going to be starting and finishing at, probably with some targets in it, and then press the button on the right side of the screen to begin your scan. And so we're now live, capturing a color 3D point cloud data set of everything we point the device at. You'll notice the green and yellow on your screen. That is real-time feedback on the quality of the points you're capturing, as well as the orange markers showing that these April tags have been recognized by Scan3D. The green and yellow is an overall quality report of each point based on angle, distance, time on target, reflectivity, etc. You'll also notice that you see these red squares showing areas that are not currently being captured by the camera. So on your far end of the spectrum, that would be a 14-foot maximum range, or on the close end, a 1-foot minimum range. Although you generally want to try and keep your device in the sweet spot of about 4 to 8 feet from the target, generally capturing from a little further back to start and then moving in closer to get more detail as needed. So as we continue to move through and build this scene, let's take a look at the settings that you have access to while scanning here by pressing the settings button on the bottom. You'll see that we have a depth cutoff option, so if you wanted to cut your maximum range to something shorter than the default 14 feet that you'll normally see, you can dial that back a little bit. We also have the checkbox on to detect April tags. Both those settings I would recommend you keep on their defaults at all times. And lastly, you do have access to a unit setting here to modify the default display units in-app. Next, we're going to touch on the other main button you have access to while scanning, which is this camera icon or action button. You can utilize this button to capture a high-res still frame from your tablet or 3D camera during scanning. So I just press and hold that button to pull up a preview of the image I'll be capturing, and then when I'm happy, I release to capture that HD still frame, typically using your tablet camera, as it is a higher resolution 2D camera than the 3D camera itself. Each of those HD photographs will be saved into your scan file with an icon showing where you were standing when the image was taken. You can also add notes to particular points in the scan by holding on that same camera icon and selecting the crosshair button as shown here to do what's called a scan time annotation, which marks that particular point to fill in details on after capture while simultaneously capturing a high-res photograph from that perspective to attach to the annotation as well. So now we're going to just continue moving throughout our scene and filling in all of the different areas of interest. It almost feels like spray painting as we can visualize what areas we have and have not captured and how well. You'll notice that I also have a few more April tags scattered evenly throughout my scene and placed on the ground as a general best practice for additional loop closure automatic improvement, but also to add the ability to reference survey control coordinates to each of those tags before optimization for added georeferencing and accuracy improvement based on survey control. That is the second function of these April tags. So at the base level they can be used to start and finish and close the loop, but they can also reference known coordinates or reference known measurements between tags before you optimize your scan. So we turn each of those tags orange anytime we have the opportunity to pass by one, and then just continue filling in areas of this scan that we haven't captured yet. You'll notice that my start and stop scanning button has lost the green circle around it, and you'll see some more red on the screen when you're in wide open areas where it's harder for the device to track. And then when you get back up against the building or the wall, more texture, more geometry, that green circle will fill in more. It's what we call the scene fitness bar, and it helps to indicate how well your device is tracking while you move through the scene. You may lose tracking, especially in challenging areas like this, which is a really important feature that we've built in to prevent you from getting any bad data while scanning. If and when you do lose tracking from a challenging area like this, or simply because you tripped or somebody walked through your scan, don't stress. Know that Scan3D cut off captured to prevent you from getting any inaccurate data, And all you have to do is slowly back up to an area you were just scanning from and capturing some good green data for it to relocalize and allow you to continue from where you left off. There certainly can be more challenging tracking situations when scanning outdoors, so you do want to make sure to take your time, be patient, and if you do lose tracking, just back up to regain it. When you're scanning along buildings, texture, indoors, things might be a little bit easier, but flat white walls can also present their own challenges. So in general, you want to follow geometry in your scene, panning along the edge of a floor wall intersection, for example, before backing up to fill in the more flat, empty spaces. Now that we've entered the terrain area of this scan, it certainly is tracking a little bit better, but it's still pretty empty over here, and I'm definitely still taking my time as I paint everything green and yellow in this particular area of the scan. At this point, we're going to speed up the video a little bit for your convenience as I continue to move through the scene, capture another HD photograph. And there is one more capability available to you while scanning that we should touch on before we finish up this scan. It's what we call the planarity constraint feature, and it can also be accessed from the camera action icon and the plane button. You see the plane turn purple and then plane pick successful up top. What this does is it recognizes that plane as a flat level plane surface, and you can utilize it multiple times when pointing at the same plane, such as a floor or a wall, or on multiple different planes that should be parallel to each other, such as the landings of a staircase or two walls that are parallel. And similarly to April tags for loop closure, it's only really helpful when you actually do it multiple times, either on the same or parallel planes. But we're not going to bother in this case. We just wanted to show you how to use it because we are in an outdoor, uneven surfaced environment. So we normally wouldn't actually use that feature in this scenario. We're just pulling it up as an example. It's definitely more intended for indoor, floor wall, staircase type scanning applications versus uneven terrain. Now we've made it all the way back to our same 3 April tags we started at. And we just touch that button on the right again to finish up our scan. It'll process in a matter of seconds, and you can have a look at your unoptimized full preview of your data set right away on your device. It's important to note that this initial preview is the unoptimized data, so any sort of blurriness, fuzziness, misalignment, duplication, overlap, completely normal at this stage, as you see a little bit in our start and finish area there. This is not representative of the final quality, but it is representative of the quantity. So it's a chance to look and see, did I miss anything? Do I need to fill in any more on particular areas before I move on with my scan? If you do determine that you need to add anything, that's when you would go to the scan/append button again and select the append capability that allows you to relocalize and add more data back into this scan before optimizing. In this case, we're happy with everything we got, so we're going to go ahead and move on to the next step, which is typically either directly to optimization or targeting first if you have targets to implement. In our case, we do have survey control points for some of these targets, so we want to add that information into .3D before we optimize. So we'll select the Targets tab up top where we see all of our recognized April tag targets, and then press Load Control File in the top left to import in the surveyed 3D coordinates of each of these tags. You always want to check your units during import, and then simply press Open Control File to select the file from your hard drive on your tablet. After which point you will be able to see a quick preview of the coordinates that are being imported, and then press Import. Now we're almost done with the target import process, but there's one more important step, which is to press the Fit Control Targets button on the top left side of the screen. And before you do so, also confirm that the handedness of your coordinate system is properly set to right or left-handed. Typically, a right-handed coordinate file will be in the formatting of XYZ or ENZ, and a left-handed coordinate file will appear as NEZ or YXZ, although you should confirm this specifically based on your own parameters and capture devices for your survey control points. So now that we've made sure that toggle is set correctly to right-handed for us, we press the Fit Control Targets button. We now have a target fit, and we can proceed to the next step, which is optimization. This is a post-processing step that you should take with virtually every scan. that is going to improve the overall accuracy and quality of your data by leveling the colors throughout the scene, cleaning up any noise that's recognized in the data, implementing any targets or control points or reference measurements if you've utilized them, implementing April tags for loop closure, implementing planarity constraints if you've utilized them, performing an overall loop closure and improvement of frame-to-frame alignment throughout your entire scan, and just in general improving the overall quality of every corner of your scan based on a variety of parameters that are taken into account. We do recommend you typically leave all defaults checked on this screen and then proceed with the Optimize Scene button. Now we have sped up this optimization for your convenience. The total optimization time for this relatively large scene on a relatively low powered tablet was about 9 to 10 minutes. That can be much faster on more highly powered devices or with smaller scenes, but in any case it is real-time, local, and rapid, and your final result is ready as soon as this optimization finishes, usually in a matter of 1 to 5 minutes for most scans. And now we see our final result. Everything is cleaned up and crispened up. Any sort of fuzziness, misalignment, duplication has all been sorted out, and we can move on with our clean and accurate color point cloud dataset. So if we zoom in here, you can really see the dense details that are captured in this point cloud with about a 2mm resolution or point spacing. So highly dense and clean point cloud data throughout the entire scan. Now, in some cases, this may be all you needed to do and you're done at this point, ready to move on to save and export, but there is a lot more you can do right here within Scan3D, so we're going to also cover a lot of that now. So first we're going to go to our Targets tab and take a look at the results of our survey control targeting. So now that the control targets have been applied to optimization, if we fit that control file again using the Fit Control Targets button, and then press it a second time, you'll see in this pop-up that we are spot on within 1/10 of an inch of our survey control targeting file. So everything looks great after optimization, and that quick check can give you even more confidence in your data moving forward. So next up, let's take a peek at our Edit Coordinates tab. In this case, we do not actually need to modify our coordinate system because the coordinate system of the control targets has already been applied automatically. If you did need to set your coordinate system or origin point manually, you would press the Set button, then select a point and select a plane for your X or Y and Z axis to come perpendicularly out of. In this case, we're all set, so we're going to move on to the Measure tab. So you can start taking measurements from any point to point within your scan right after you've captured it. You just select to start a new measurement, and then you press and hold on your scene to get a zoom window of the point you're measuring to and from in the top right. And you'll see not only your point-to-point distance of 99.15 inches, but also your change in X, change in Y, and change in Z based on the set coordinate system or your survey control coordinate system. You can take as many measurements as you'd like, and they all save directly into your .dp file, and can also be duplicated easily to dimension around the edge of an object, for example. You can adjust these measurements very easily. If you didn't quite get the point you were trying to select, you just press that green circle and then move to reset. Next up, we're going to cover the Annotate tab, where you see we have a 1 next to the icon indicating the 1 scan time annotation that was already taken. And we're going to first complete that scan time annotation before adding more new annotations. So when you press complete, you'll see the photo that was taken, and then be prompted to choose between a photo or a point annotation depending on if you want to keep the photo attached, and then fill in the relevant details and press OK to confirm. Then you can press complete, and now all your scan time annotations have been saved, and you can move on with adding any more annotations you want to add in a more traditional sense of just pressing Add/Detect on the top left side of your screen. And then similar to measurement, you press and hold and then release when you're happy with the point you're selecting. Choose your annotation type and add all the relevant details to each annotation that you're adding into your scene. Next, somewhat similar to the scan time annotations, we're going to take a look at the HD photographs that were captured while scanning by going to View High-Res Photos. You now see a bar on the right side of the screen that can be pulled up with each of these high-res image thumbnails. If you tap on them, you will navigate to them in the 3D view, and if you hold on them, you'll be able to pull up the full high-resolution 2D detail of that image, where you can also then slide through the other images that were captured, and then when you back out and zoom out, you can actually see these icons showing where you were standing and pointing when each of the images was taken. And when you're done looking at these high-res photos, you can just back out using the top left button. Now let's take a look at some of the other options you have in the View tab in the top right. You can toggle between different vantage points, turn your axis rendering on and off, turn your planarity constraints viewing on and off, and switch between perspective and orthographic viewpoints. So we're going to switch to an orthographic view now. And next up will be cropping and hiding. So I'm going to navigate up to the Edit tab and select Cropping. And we now have this rectangular selection box that can be moved around. You can still move your scene with a 2-finger drag or mouse pan, but you can also move the rectangle itself using the 2 green circles. So this can be utilized to either select or deselect the area that you want to keep or the area that you want to crop out. In this case, we're going to select all of the areas that we want to crop. So anything that you're going to be cropping or fully deleting from your scan will be highlighted in red as I move through the scene and select all of the areas that I want to delete. Now, in addition to the cropping tool, which permanently deletes these points from any saves you have, leaving .3D in the DP or another format, you also have the hide tool, which will hide those points from view without actually deleting them when you export to different formats. So we switch to hide mode in the top left and select the top of the wall here, and that now gets highlighted in blue. So when we back out of the crop tab, both the red and the blue will be gone, but if you were to move forward with the data elsewhere or otherwise go back to the hide/crop tab in .3D, the data that was highlighted in blue or hidden would still be available to you. Now that covers the vast majority of functionality available to you here in Scan3D, but as mentioned at the beginning, we do recommend that you explore other settings or other functionality that you may find within the app, but that does cover the bulk of it. The last step with most scans is to save and or export. So if you're going to be saving your scene first, that would be saving to the native DP point cloud format. You want to go to Save As, and make sure to select the output transform that is most relevant to you. So if you have applied survey control as we did today, then you'll want to have control targets checked, as it probably will be by default. Or if you've manually set a coordinate system by selecting a point in your scene, then you would use the user-defined option, etc. After you've saved your scene, if you want to export to another format to be utilized in a third-party application, you can go to the File Export tab where you can export directly to point cloud formats such as RCS, PTS, PTX, PLY, E57, PTG, LAS, and LAZ. Thank you for taking the time to view this tutorial, and happy scanning with Scan3D.